Anyway, okay. All right. So let's go through the different types of transformations because a lot of you were trying to change your equations in the exam without trying to sub things in. You were just trying to do it manually by going, let's just add a 1 in here or do something over there. And it messed you up a bit. Okay? So if we are trying to shift something horizontally to the right, okay, so H spaces to the right, going to the right is the positive numbers, so we have to subtract H. We would sub in X minus H. Whereas if we go to the left, which is the negative numbers, it becomes an X plus H that we're going to be subbing in. Opposites, remember? Then up, if we're going vertically, this is the Y direction. So that means we're going to replace the Y with Y minus K. Up, going up is Y minus K. Yeah, opposite to what you would think. And down is Y plus K. If you're going to reflect something in the y-axis, you replace x with negative x. You're reflecting it over. If you're reflecting in the x-axis, so from y's up here, you want to go down there, we're replacing y with negative y. We can do a full 180 rotation, which is the same as changing x with negative x and y with negative y, reflecting both of them. A vertical dilation is a stretch of a factor A about the x-axis. So if I want to, maybe 2, I might be trying to stretch it by a factor of 2. Into your equation, you will replace the y with y over A or y over 2, whatever the number is that you're trying to stretch it by. Okay? Which means if you had a fraction in there, so if I'm trying to stretch it by a half, I would be putting in y over a half, or in other words, 2y. Okay, so you've got to think putting the 2 in front of the y actually means it's a factor of a half. You're actually compressing it. Horizontal dilation just means we're going to the x-axis and doing the same things. Okay, so we've seen all of that before. We are focusing on exponential graphs today in this first exercise. So consider the exponential graph. We've seen them before as y equals 2 to the x or y equals 5 to the x, but we're putting in here y equals e to the x. We've learnt about e before in terms of using logarithms of base e, but we didn't spend a lot of time on sketching them, which is what we will be doing now. So you can see that y equals e to the x, it has the same shape as what we would expect for an exponential graph. It has the same y-intercept, which is 1. This is just a tangent through here, so don't stress about that. And it's just shown an extra point. If x equals 1, we would get y is equal to e to the power of 1, which is about the 2.7 decimal that e is equal to. So y equals e to the x is a special exponential, which is why we highlight it so much, because it is the only graph in which the derivative is the same as the original equation. That's why it is so special. So, some things to note. The gradient at the y-intercept is 1. The domain is all real numbers, and the range must be greater than 0, because you've got an asymptote there, it's got to be greater than 0. The line y equals 0 is a horizontal asymptote, so can't forget that one. The function is 1 to 1, which is normally what we would consider to be like a straight line, 1 to 1. One x value has one y value, so an exponential is the same. And then look at this next part. So the asymptote's 1 to 1. Differentiating e to the x once, you get e to the x. Differentiating the second time, you still get e to the x. Differentiated the third time, you still get e to the x. Doesn't matter how many times you differentiate it, you will always get e to the x. The function is always increasing at an increasing rate because it's getting steeper and steeper as it goes up, and it is always concave up. Okay, so let's draw. Example number 1. Sketch each function using a transformation of the graph y equals e to the x. Describe the transformation, show and state the y-intercept and the horizontal asymptote, and write down the range. So the first one, y equals e to the negative x. What does that little negative sign do? Reflects in the y-axis, because it wanted a description, so let's write it down. Reflect in y-axis. Because I basically replaced the x with minus x. So, to draw it, if you're looking at the graph at the top of the page, it's still going to have a y-intercept of 1, but it's now going to be small on the right side and coming up much steeper on the left side. Okay, the things we had to show. State the y-intercept, done. The horizontal asymptote, that's going to be across here, that hasn't moved. So that'll be horizontal asymptote at y equals 0. A proper sketch should probably show an extra point. So let's put in -1, and what would the value up here be at -1? E, very good. So this is the point -1e. And I meant to also write down the range. What's the range? Yes. Y is greater than 0. All right, next one. Y equals e to the x plus 5. What have I done? Yep, moved up 5. Okay, what do you think I should draw first in this moving up 5? Yes, very good, Grace. Start with, well, the axis. Thank you, Tyler. Had to go for the smart aleck response. Okay, so the horizontal asymptote, which is normally here at 0, that's the best thing to move up 5 first. So let's go across here. Here's my horizontal asymptote, now at y equals 5. The rest of my curve is going to have the same shape as the one at the top of the page, which means my y-intercept will be there, but what's the coordinates of that point that I just drew? 6, because it's always 1 above the asymptote. Okay, it's going to be going the normal direction, small to big as you're going from left to right. And if we put an extra point on here, it would be the point 1, what? E plus 5. So it's 1, comma, E plus 5. Okay, good. What is the range? Yeah. So range y is greater than 5. Good. Next one. C. Y equals e to the power of x plus 3. What does that power of x plus 3 do? Move to the left 3 spaces. Move left 3. Okay, has my asymptote moved? No, okay, so that's going to be still at 0. So across here, horizontal asymptote at y equals 0. If I've moved my graph to the left, the intercept that is normally here at 1 will now be over here at -3, 1. So let's put that here, -3, 1. And my graph is going to come up, but I should also find out what that intercept is. The intercept is when x equals 0, which means e to the power of 3. So that value there is e to the power of 3. And what's the range? Y is greater than 0 again. Just making sure I do everything the question says. Okay, next page. Question 2. sketch each function using a dilation of the graph of y equals e to the x. We're going to start stretching in the x or y direction. So y equals e to the 4x. The 4 is with the x. So am I stretching horizontally or vertically? Do we agree? Horizontally, because x is the horizontal axis, so we're stretching the x. Now, what factor are we stretching or shrinking by? A quarter. The table at the front said that it needs to be, if you're replacing x with x over a. But this is not x over anything. It's a 4 up here next to it, which means it would be the same as x divided by a quarter, because you'd flip the 4 back up to the top again to get 4x. Does that make sense? Yes? Okay, so we are dilating or dilate horizontally with a factor of a quarter. Okay, so we have to draw it. The asymptote has not moved, so it'll still be down here at 0. Horizontal asymptote at y equals 0. What about the intercept? Where will the y-intercept be? You can check if you're not sure. It's still going to be the same. Yeah. You'd sub in here that x is equal to 0. 4 times 0 is still 0. E to the power of 0 is equal to 1. So it hasn't changed. My y-intercept is there. So what is happening, this quarter, means that the graph, which might have started this big, is going to get squeezed in this way, a quarter of the size. So instead of it being 1e that I normally have here, if I sub 1 in here, what am I going to get? E to the power of 4. It's 4 times bigger because it's been squished in to that much less space. Okay? So we go 1 down here. It'll be way up here. And that is 1 e to the power of 4. Okay, part B. Am I dilating vertically or horizontally? Vertically. The 4 at the moment is over here with the e to the x, but normally we like to, if we can move it across to the other side, we would get y over 4 equals e to the x. Then you can see, here's my y over a part. Okay, so it's with the y now, and it's in that lovely fraction form, which means I'm dilating by a factor of 4. Okay? Vertically. So I'm going to dilate vertically with factor 4. Okay. Horizontal asymptote will still be the same. Make sure you always draw it though. Things that we always like to give marks for, so it should be easy marks. Okay? My intercept, normally it's at 1 here. Is it still at 1? No, it's now 4 because I've stretched it, right? And you can check it by subbing in. If you sub in x equals 0, because that's your y-intercept, e to the 0 is 1, times by that 4 makes it 4. So here is 4. When we sub in x equals 1, we get 4e to the 1, or just 4e. So I'm going to draw my curve up here. And then at 1, that's 1 comma 4e, showing that extra point. Everyone still okay? Yes, good. All right, moving on to question 3. Let A be the point on the curve y equals 2e to the x, where x is equal to 1. Find the equations, that's plural, of the tangent and the normal at the point A. Okay, we're moving straight into finding tangents and normals, which is when you have to differentiate things, find a point, and then find the equation using the point gradient formula. So the derivative of e to the x is e to the x, right? The 2 sitting out the front is just sitting out the front. It's not going to do anything. So the derivative of 2e to the x is still 2e to the x. Okay, now I specifically want the tangent and normal when x is equal to 1. So let's sub in when x equals 1. My y dash would equal 2e to the 1. Often we don't even write that little one, we just write 2e. Alright, so just 2e. That would be the gradient of my tangent. While I'm here, the gradient of my normal, so the gradient of the normal is equal to the -1 reciprocal of that. So it will be -1 over 2e. Okay, I have a gradient of you can write a little note there if you want to, that this one here is the tangent. So I have the gradient of my tangent, I have the gradient of my normal, and I need to find the equations of both of them, which means I also need a point. Do I have a point? I have an x value, it's not a point. All right, so what do? Sub 1 into there. So my point is going to be 1, because that was the x value, and then 2e to the 1, or just 2e. There's my point. Okay, now here comes the equations. Let's start with the equation of the tangent, which means I'm using that gradient and this point. Okay, so point gradient formula is y take away y1, which is 2e, equals m, which is also 2e, bracket x take away x1, which is 1. Okay, don't let all those e's in there freak you out. We just need to expand it out and get the y by itself. So y take 2e would be equal to 2ex minus 2e. And if I add this 2e across to that side, what happens? They cancel. So it's just y equals 2ex. That's pretty cool. The equation of the tangent goes through the origin and has a gradient of 2e. But anyway, interesting stuff. Now let's do the normal. So over here, equation of the normal. So this time I use the normal gradient, same point. Okay, so y take away y1, which is still 2e, equals new gradient, which is -1 over 2e, x take 1. Now, unless the question specifies, you do have options here as to whether you are going to try and get the y by itself, which means you've got some yucky fractions in here, but you just want to move that across the other side, or go to general form and get rid of all the fractions. Let's do general form, because we did this one and that one. Let's do this the other way, so we can practice getting rid of the fraction. If I times the 2e on the denominator here, I'm going to times the 2e across this side. So that would be 2e times the y, and 2e times 2e makes 4e to the power of 2, or e squared. E times e makes e squared. Okay, equals. Now I didn't do the minus sign, so I'm going to expand the minus 1 through the top there. So it'll be minus x plus 1. Whoa, lines. Okay, then general form means I want x first and positive. There's my x term. It's negative, which means this stuff, I'm going to move it to the other side. Have the x term first, y term second, and these two things are constant at the end. Okay, so positive x plus 2ey minus the 4e squared plus 1 equals 0. Oh, that must have got deleted when I erased my line. Thank you, you're right. It should be a minus 1. Delete that big weird line that came through. Okay, good. Question B. Show that the tangent A passes through the origin, oh, we kind of already know that, and find the point B where the normal meets the y-axis. Okay, first things first, how do I show that the tangent passes through the origin? Even though we can kind of already see that, but sub in x equals 0, perfect. Sub x equals 0 into, maybe I should number some things. This was my tangent equation, so let's call that equation 1. And I'm going to need this equation as well, which will be equation 2. So I'm going to sub that into equation 1 to show that my tangent goes through the origin. So that would be y equals 2e times 0. Anything times by 0 is still 0, which means I subbed in 0, I got 0, it passes through 0, 0, right? So therefore, passes through 0, 0, which is the origin. Okay, next, second part of that question says find the point B where the normal meets the x-axis. Okay, the normal means I'm looking at this equation and I want to know where it meets the x-axis, which is when? When y equals 0. So let's divvy this up down here, and I'm going to sub y equals 0 into equation 2 because that was my normal equation. So that makes x plus 2e times 0, that's just going to disappear, minus 4e squared minus 1 equals 0. So that means that x by itself, move your constants over to the other side, 4e squared plus 1. So the coordinates of B, because remember it called this intercept, find the point where B, where the normal meets the x-axis, is going to be x equals 4e squared plus 1, comma 0, because it's the x-intercept. Part C. Sketch the situation and find the area of triangle AOB. Okay. The original question was, or graph, was y equals 2e to the x. Let's draw that. So y equals 2e to the x has an asymptote down here at the bottom. I'm not going to worry about that too much because it's not all about that asymptote. What's my y-intercept? 2. Good, because that 2 that was in front of it. So y-intercept is about there. And let's just sub in 1. If you subbed 1 into the equation, what would you get? 2e, which was the point that we actually were given in the question. So here comes my exponential. up here, this point, I'll put it over here so I have some room on my diagram. There's my 2e. So there's my exponential. Now, at the point where x equals 1, at this point, we need a tangent, and the tangent goes through the origin, remember? So try to wiggle your diagram a little bit so that your tangent, I'm going to change colours. Maybe I'll start from the origin and go up. Oh, that's a terrible tangent. There you go, my tangent goes through the origin and comes up and touches at that point. Then I also have a normal, which, if you wanted to know roughly, 4e squared plus 1. There's my calculator. 4e squared plus, oh, it's massive. Way down there. So here comes my normal, not to scale, definitely. Okay, so that should be a right angle because tangent and normal meet at right angles. And this is meeting down here at the point B, which was the 4e squared plus 1 comma 0. And that green triangle is the A, that was the original point, A up there. O stands for the origin, so there's my A, O, B. I want the area of that triangle. How do I find the area of a triangle? Half base times height, assuming that I can find a right angle. I do have a right angle there. Is that a right angle to use? Do I know that side and that side? That's a bit of a pain. How about instead, chop it down here. Still one triangle, but that, I'll draw it on here. This height we've already found is 2e. And the length of the base of the triangle is that, 4e squared plus 1. Okay, so it is half times my base, which is 4e, is that sitting on again? 4e squared plus 1, times by the height, which is 2e. Okay, now that 2 can cancel that 2. Let's times the e into the bracket, and we would get 4e cubed plus e. Or you could leave it factorised if you prefer, I don't mind. Okay, so that would be it. Technically that would be units squared, it's an area of something. Okay, done.